My name's John, and this is my Line Tracker report. We had to design a robot that was able to follow a black line on a set course, and it would have to have no issues, and it would also have to count the lines and stop after a certain amount of time. I chose to go with a small footprint. This allowed me to, initially, I thought you could put the line trackers anywhere on the thing, because all you need to worry about is where the sensor is. And I had 3 sensors, and my design was, say, one sensor would be on center, so it's straight ahead all the time, one on left that would say turn right a little bit, or sharply, depending upon what sensor's high, and the same for the other side. At the beginning I had a rotor for the back part Omni wheel, but I found that that wouldn't allow me to get 180 degrees rotation, so I had to remove that, change it up to 2 motors, one for left side and one for right side, and have a free rotating wheel. It was a little difficult using a small frame because it wouldn't allow any expansion on the inside, so I had to put stuff on the outside and kind of account for the weight because everything's on the top. I have to center it, and I gotta worry about that. Code-wise, we still have the LCD code from the other labs. Just say, get the LCD to run and have, servo defined. We set it up so we had the motors on pin 39 and 41. Same thing there. Objective 1 was to run the thing on when the sensors read over 800, and that would display whatever it is. I had it set up, just these different conditions, like if these things are high, run this, display this, and write these values to the motor. And it took a little bit of tweaking because I had to worry about overdriving, because when the motor turns off, it's still going to go forward, so you have to kind of adjust that. The count for objective 2 just says when the count is not, while count is not 3, just keep running the program, and it tracks the lines, and then when the count's done, it stops the loop. And I had it set up so that a friend of mine, well, not a friend, but a colleague, Elliot, he suggested, put a delay in there. That way it can track line, but it'll be like a 1.5 second delay where it won't count the line, so it'll allow it to go past. I found an issue with the motors. It seems like the power output for one direction is not the same power output for the other direction, so I had to kind of tweak it a lot, because you can see right here that it'll turn to the right no problem without stopping, but once it hits the left part, it has to stop, turn, and that was just an issue that caused me a lot of problem, because I couldn't just say, hey, go 90 and go 5 back in each direction, you'll get the same speed. No, you have to tweak and tweak and tweak, and that was a little tedious for me, I think. Yeah, that's my entire thing. I think if I did this project again later on, I would make sure that I have a good space for gearing and accommodation. You'll see this is objective 2. It does the count. I didn't include the first line, so it bypassed that. And it does 1, 2, 3. 3 is going back, and it stops again. I think the next time, as I said, is I would try to build it in parts, because the sensor can be mounted anywhere, like the line sensor. It just has to be a certain height off the floor. So I think I would worry about the wheels and the gearing first, and then build around that, because with that small frame, I wasn't allowed to put anything inside. I originally had the gears in there, but that wouldn't let me put any more motors. It wouldn't let me put anything, important in there. I couldn't even put wires in there because it was too short. I used corner pieces, and that didn't have really enough stability. You can see the gear, not the gear, but the shaft is not really aligned properly. But that was pretty fun, and that's the end of my project. Thanks for watching.